Assalamualaikum and welcome everyone. Today I will talk about integration, specifically in the techniques of integration, and we are going to discuss simple example on integration techniques such as substitution method, tabular method, and partial fraction method. Okay, the key to substitution method is finding a piece of the function whose derivative also in that function. So in this example here, there are two similar groups of equation. So we can find that when we derive x squared plus 3, we will get 2x, which is occur on the denominator here. So this is the key of knowing that this must be the substitution method behind this one. Okay, so let's go to the method given. So first we need to define what is u. So u here, we always choose the denominator. Always choose the denominator. So u equal to x squared plus 3. Then when we have u, we want to substitute all the term of x here in term of u. So here we have dx. So we want to convert dx into du term. So how to get the du? So we need to differentiate du over dx. So we may differentiate the x squared, we will get 2x. Okay, and then we rearrange until we get dx equal to du over 2x. Okay, next we substitute back into the equation here. So we have 2x, this similar thing. Okay, we just copy the one. Then we have over x squared plus 3 is equal to u. Okay, just now we substitute with u. And dx here we have du over 2x. Then we can simplify because this is multiplication term, so we can simplify 2s and 2s. Then we will get only 1 over u du. Okay, so follow to the formula here. So fx, and we differentiate fx, it is at the numerator, so we can simply convert it into ln u plus c. Okay. So once we get the answer, then we can substitute back the value of u, which is ln x squared plus 3 plus c. Okay, so this is the solution for 2x over x squared plus 3 dx. Okay, we move into another example here where we have 2x, x squared plus 1 power 3 dx. So first we need to identify what is u here. Okay, it's more to common sense. Okay, for me, I will choose u equal to x squared plus 1. Why? Because I can see that the derivative of x squared, we get 2x, which is outside the bracket here. So we choose u equal to x squared plus 1. Then from u here, we find du dx. Why we have to find? Because we want to substitute into dx. So du dx here is equal to 2x. Okay, so next, from here we can get dx is equal to du over 2x. So next we substitute into the formula. So we have 2x remain 2x. Then we substitute just now. We have x squared plus 1 is equal to u. So we have u power 3. So dx is equal to du over 2x. Okay, so if we have x, we cannot find the derivative, find the integration yet, sorry. So we have to remove. So in this term, we can simplify 2x and 2x here because of there is a multiplication form. Okay, so we have u3 du. So when we integrate this one, we will get u power 4 over 4 plus c. Okay, so when we have finished the integration, then we can substitute back into original form, which is x squared plus 1 power 4 over 4 plus c. So this is the representation of integration of 2x squared plus 1 power 3 dx. Okay, which is equal to x squared plus 1 over 4 plus c. Okay, we move to the second technique of integration, which is tabular method. So it is an alternative method for the integration method. Before this, maybe you have learned about the integration by part, but for this slide, I will show you only for the tabular method. Okay, so in tabular method, we will have some table here. where we will have u and dv, similar to the integration by part technique. Okay, so with u, for u, we will always make sure that we will differentiate. Okay, differentiate at every level. And then for the dv, always make sure that we integrate. Okay, for every level. So for u, if u is a polynomial, we will differentiate until we get 0. Okay, if u is a trigonometric, we won't get 0. So we can just differentiate until we get back the same function of u. Okay, so let's move to the techniques of the tabular method. So example here, how do we know that it is tabular method? Okay, so for me, I will look first at the types of the groups here. So we have x and sine 3x. So it is not likely to be substitution method, because substitution always involve two functions that involve derivative of another function. Okay, so in this case, we have different types of groups, so it might be tabular method. Okay, so let's try for this example. So first, we need to identify what is u and dv. So how to choose for u? You must need to follow the priority, which is Lopez. Okay, so L stand for ln, P polynomial, E exponential, and 3 trigo. Okay, so the priority must follow L, P, E, T. Okay, so when we look here, we have polynomial and trigonometry. So the priority here lie on the polynomial first. So polynomial will be chosen for u. So the rest will become dv. Okay, so you always make sure we differentiate until we get 0. So differentiate x, we get 1. Differentiate 1, we get 0. Okay, finish until this line. So for the dv sine 3x, we need to integrate. So sine 3x, we integrate, we get negative cos 3x over 3. So next, we integrate one more time, we will get negative sine 3x over 9. Okay, so when we finish integration until the last level, okay, so next we put sine here. So I always put sine on the left side, it's up to you, plus, minus, plus. Okay, so for the first level, it will go to the second level on the right side. Okay, the same thing goes to the second level on the left, goes to the third. Okay, so for the final level, okay, we must always make sure that we multiply both and integrate both sides. Okay, so we will get the value is, so x sine 3x dx is equal to, so x multiplied by negative cos 3x over 3 we will get, then positive value, so negative x cos 3x over 3. Okay, so here we have negative, so it will become positive. So 1 multiplied by sine 3x over 9, so here the answer is sine 3x over 9. Okay, next, negative, positive, so we get negative, then always put integrate. So sine 3x over 9 multiplied by 0, we get 0 dx. Okay, so the answer will be negative x cos 3x over 3 plus sine 3x over 9 integrate 0, which will become constant. Okay, will become constant. So this will become our solution. Okay, we move to the second example here of tabular method. Okay, so how do we know that it is tabular? So for me, I choose because there are different groups. Okay, so we have exponent and trigonometry. Okay, so first we choose for the u and dv. So u must follow the Lopez. Okay, so since we have exponential and trigo, So the exponential comes first, so it will be chosen as our u, e2x. Then we have dv cos x. Okay, exponent to x, we differentiate, we get 2 exponent to x. Okay, and then we differentiate one more time, we get 4 exponent to x. So next for the cos, we integrate, we get sine x. Next we integrate one more time, you will get negative cos x. Okay, so we make a cross section here from section to section. Okay, so the second to third and the final, we always make sure that it is integrated. Okay, then put the term, the sign here, plus, minus, plus, and so on. Okay, so this our solution will become e2x cos x dx equal to, so plus multiply by plus, we get plus, so we have exponent 2x sin x, minus minus, we will get plus. Okay, so we have 2 exponent 2x cos x, and then the final section we have minus plus, we will have minus, integrate for e to x cos x. Okay, so we want to integrate exponent to x cos x, but the same function occur on the right side. So when we want to integrate the right side here, so what will happen? It will get the same answer like the right side here. Okay, so I give you some hint here. Okay, so let's say we want to solve x. Okay, but there is another x occur on the right side. What should we do? So we will bring this one to the left side, then we get minus x equal to 2, so x equal to negative 2. So the same thing goes to this solution. Okay, so means that we can bring this one to the left side. Okay, so let's try to move this one to the left side. Okay, so we have, so since this one, this is 1, this is negative 4. Okay, so we bring this one to the right side, we will have 1 minus 4 is equal to minus 1 minus 4, so means that we will have plus 1 plus 4 equal to plus 5 exponent 2x cos x dx, because we assume that this one as x, so this one as x. Okay, so equal to exponent 2x sin x plus 2 exponent 2x cos x. Okay, so just put plus c because we already do the integration part. Okay, next we want to get the only this term. So since we only want to have exponent 2x cos x dx, so 5 we can bring to the right side, we will get 1 over 5. Okay, exponent 2x sin x plus 2 exponent 2x cos x plus c. Okay, so this will become our final solution. Okay, we come to the last technique of partial fraction. Okay, so there are 3 tips that I want to share with you. The first tip is to check whether the integration is proper or improper fraction. Okay, so let's say we have fraction of p and q. Okay, so if degree of qx, okay, is greater than px, so it is proper fraction. Okay, while if the degree of px, okay, greater or equal to degree of qx, then we consider as improper function. Okay, so if we have this kind of equation, okay, so the degree of px is more higher or equal to the px, so we need to perform long division first to get the partial fraction. Okay, so another tips here that I want to share with you is to set partial fraction based on the denominator. Okay, so means that we need to factorize the denominator so that we can solve by the partial fraction. And another tips is to find the a and b, all the constant here. There are two ways whether we can substitute any value of x. X can be any value. Okay, whereas a and b are a fixed value of a constant. Okay, or also another way to find a and b is we can compare in terms of the coefficient. Okay. Okay, so let's move to the example here where we have a fraction form. So first we have to check whether the power of the denominator, the degree should be always higher than the denominator. Okay, so if we can see here x multiplied by x, we will get x power 2. So the power here is 2, okay, which is greater than numerator. Okay, so we can solve by using this one, by using partial fraction. Okay, so the condition for partial fraction, we must ensure that it can be factorized so that we can split into partial fraction. Okay, so we just omit the integration part. So I copy this one back. So we have 1 over x minus 2, x plus 1. So we will have the term is equal to, so a over x minus 2 plus b over x plus 1. Okay, so this one is equal to another form, okay, which is partial fraction. So we want to make sure that the denominator on the right side here is equal to the left side. So we copy back the same denominator on the left side. So we have x minus 2 and x plus 1. Okay, so since this is equal, so a over x minus 2, we want to make sure that the denominator is equal to the same here. So x minus 2 must multiply with the x plus 1, right? So the same goes to the numerator here. It must also be multiplied by x plus 1. Okay, so the solution we get a multiplied by x plus 1. Okay, plus b. This one also multiplied by x minus 2. So the upper here multiplied by x minus 2. Okay, so we check back. If we can simplify, we will get back the same answer with the previous solution. Okay, so next, when we have the same value of the denominator here, okay, we can simply take the numerator only. So 1 here equal to a x plus 1 plus b x minus 2. Okay, so we have an equation here where we want to find a and b. So how to find the a and b? So there are two ways to find a and b. So first, we can solve by using comparing the coefficient here. Okay, so maybe we can compare in terms of x, or another way is we substitute value of x. Okay, so let's move. Let's try another one way, option 1. I try to the option 1. So we try to substitute. So we use let x. X can be any value. Okay, so bear in mind x can be any value. So x, let's say we choose x equal to -1. Okay, so we just substitute into this form. Okay, so we get 1 equal to a x 1 minus 1. Sorry. So we have -1 plus 1 plus b x equal to -1 minus 2. Okay, we just copy this from here, from this equation. Okay, so we get -1 plus 1, 0. So we get 0 here. Then we have -3b equal to 1. Okay, So b here equal to negative 1 over 3. Okay, and then we choose another value. Let x equal to 2. Okay, so we will have, just substitute the value here. 1 equal to a, 2 plus 1 plus b, 2 minus 2. Okay, just substitute. Then we can simplify. This one, 2 minus 2, 0. Yes. Then we have 3a equal to 1. So a equal to 1 over 3. Okay. So from here, we can get value for a and b. Okay, so we just substitute back into the partial fraction. So we know that 1 over x minus 2, x plus 1 is equal to a over x minus 2. So we just substitute a equal to 1 over 3 x minus 2 plus b, we have negative 1 over 3 x plus 1. Okay, so means we want to integrate this one, so it is equal to, we integrate this side. Okay, so this is constant, we just bring out 1 over 3, integrate 1 over x minus 2 dx, minus 1 over 3, so we have 1 over x plus 1 dx. Then we recap 1 over 3 ln x minus 2 minus 1 over 3 ln x plus 1 plus c. Okay, so this will become our solution. Okay, let's make some summary on the partial fraction given. So let's say we have the form of 1 over x minus 1 x plus 1. Okay, so the partial fraction will become a over x minus 1 plus b over x plus 1. Okay, what if we have 1 over x minus 1 x plus 1 power 2? So the partial fraction will become a over x minus 1 plus b over x plus 1 plus c over x plus 1 power 2. Okay, so next, what if we have x minus 1 x squared plus 1? Okay, x squared plus 1. Okay, we do not care about the numerator, it doesn't matter as long as the power is always low, okay, lower than the denominator. Okay, so we can solve by using partial fraction. Okay, so to split this one, we have a over x minus 1 plus, when we have x squared plus 1, so the power 2 is inside the bracket itself, so it will affect the value of the numerator. So we have b x plus c over x squared plus 1. Okay, what if we have x minus 1? We have x squared plus 1 power 2. So the answer will be a over x minus 1 plus b x plus c over x squared plus 1 plus dx plus e over x squared plus 1 power 2. Okay, so when we have power 2, okay, outside the bracket, make sure that we expand that one. Okay, if we have power 2 inside the bracket, so means it will affect value of the numerator. Okay, so value here, we do not care too much, we just focus on the value of the denominator to get the partial fraction. Okay, so that's all. So thank you for watching this video.